All right, so the last section in chapter 4 is on triangles and coordinate proof. So basically, we're going to look at how we need to place a triangle in a coordinate plane to do a proof. Okay, there's many ways you can say place a triangle that has sides 3, 4, and 5 in a coordinate plane, but certain ways are easier than others. Okay, so we'll try to figure out what the easiest way is. So the kind of proofs we've done so far, we've done 2-column proofs. We did a lot of those. I think we've done a couple paragraph proofs. I showed you a flow proof, but we didn't do one. That's where you have boxes and arrows pointing from one box to the next. Usually the reason is above or below the box. Or on the arrow too. Okay. But we're going to look at what's called a coordinate proof. So in a coordinate proof, you take a figure, you put it in a coordinate plane, okay, on a grid, and then all you have to do is use formulas. A lot of times you use the distance formula. Okay, that one comes up a lot. Sometimes we'll use the midpoint formula. And you use those formulas and theorems to try to prove statements about the figure. Like if I said to you, prove that the following triangle is isosceles, you'd have to measure 2 of the sides and show they're the same. Right, so a lot of people like these proofs better because you don't have to think about the statements and reasons. You're just using a lot of the same formulas over and over. Okay, and one formula we are going to use quite a bit today has to do with right triangles, and I just want to make sure people know what that formula is. Anybody know the name of, it's a theorem. So theorem means you need to prove it, but we're not going to prove it in this class. But it's a theorem involving the sides of a right triangle.
Pythagorean theorem.
Yeah, the Pythagorean theorem. It's Pythagorean theorem. Anybody know what the formula is? How we normally use certain letters, but again, you can use any letters you want, really. Luke?
A squared plus b squared equals c squared.
Yep. A squared plus b squared equals c squared. What's A and what's B?
Legs.
Yep, those are legs. And C?
Hypotenuse.
Yep. So these are legs. Let's try that again. And hypotenuse. Right, so the idea is this theorem is used to find the length of a side in a right triangle, as long as you know the other 2. This side would be A, that side is B, that side is C. So if you know A and B, you can find C, or if you know A and C, you can find B, any combination. You just have to have 2 out of 3. And the Pythagorean theorem only works with right triangles. Right, so there might be times today when we use this theorem. There might also be some other points where we use distance formula. Okay, but the distance formula is really this formula. They're the same formula. Okay, so that's your Pythagorean theorem, used to find the length of a side in a right triangle only. All right, first thing I want to do is I just want to practice trying to place a figure in the plane. Okay, trying to find a spot that we can place a shape that makes it easy to work with. Okay, we've got a rectangle. The rectangle is going to be 2 units by 6 units. And I want to try to place it in a good spot that would make the vertices easy numbers to work with. Anybody think, in general, where could you place this rectangle to make it easy to work with? Okay, and if you're not sure exactly what I mean, let me show you a placement that would not be easy to work with. Let's take this rectangle and place it like that. That would be hard to work with. All your vertices now, they're going to be decimals. It's going to be kind of challenging. So what would be a better place we could put that? Luke?
Like along the lines of the coordinate plane.
Yeah, if you could position it somehow along the axes, just like that. You know what? Let me make it, just make it a different color. Okay, so if we put it right along the axes, that's going to make the coordinates very easy. One of them is going to be 0, 0. Okay? In fact, every coordinate here is going to have a 0 in it except for one of them. Okay? The top left is going to be 0, comma 6. Okay, the top right, that's going to be the one that doesn't have a 0, 2, 6. But then the bottom right, that's going to be 2, comma 0. And the bottom left is 0, comma 0. So that's one good place you could do it. What would be another good place besides putting it that way? I can think of one other way you could do it, and it would still be just as good. Yeah?
In the middle of the y-axis.
In the middle?
It's a negative and a positive.
Okay, yeah, that's not a bad idea. So if you put it in the middle, especially if you're finding a midpoint now, it's going to be symmetrical. So you're going to have some things canceling out, like -1 plus 1. Add them up, you get 0. Okay, gives you your midpoint. Yeah. Another place you could put it, if you did it in a more horizontal, you could place it right there. That would be good. I probably wouldn't place it here. Why would I stay away from putting it there? Because of what kinds of numbers? Yeah, then now you got to deal with negative numbers. Okay, but placing it like that, I would say that's fine. But most people tend to go with that one or that one. Okay, so that's part of the process when you do a coordinate proof. You have to figure out the best place to put it. Okay. Yeah.
Those triangles same size.
What's that?
Yeah, the triangles, the rectangles the same size.
Are they the same size? Yeah, I think so. Yeah. Well, yeah, they're both supposed to be 6 by 2. I think one's just a little bit off, though. Yep. Okay. Any other questions on that? All right. So any of those answers we went over would be good. All right, here's another one. Okay, this time it says a right triangle has lengths of 5 and 12. I want to place the figure in the plane and then label the coordinates of the vertices. Okay, and then we'll find the length of the hypotenuse. Okay, how would this be? What would be a good way to do this one? Maybe let's think about which quadrant, because you could get this triangle all in one quadrant. What would be the best quadrant to put it in? Yeah.
1.
Yeah, put it in quadrant 1. How would you do that?
Well, I would put the 12 going vertical.
Okay, the 12 vertical, yeah.
And the 5 horizontal.
And the 5 horizontal,
And
okay.
have it at the origin.
And have it at the origin. All right, so if we're going to do it that way, you would do it like that. You said the 12 going vertical and the 5 horizontal, and you said have it right at the origin. Yeah, that's a great place to put it. Anytime you can get the sides on the axes, that's a good idea to do it that way. Okay, let's label our coordinates. Okay, Connor already said that coordinate was at the origin. Alyssa, what's the coordinates for the origin?
0.
Yep, 0, 0. Okay, now this one, all we've done is go right 5. Sarah, what are my coordinates if I go right 5? 0, 5, that would be up.
It would be the opposite.
Yeah, so what would that be?
So
5, 0. Okay. So remember, x comes first and then y. All right, now how about that one, Sarah? What would the coordinates be if you went 12 up? 0, 12. Good. Okay, and now let's find the length of the hypotenuse. That's the last thing they wanted. Okay, what theorem could we use to do that?
A squared plus b squared plus c squared.
Yep, what's the name of that?
Pythagorean theorem.
Yep, Pythagorean theorem. Good. So a squared plus b squared equals c squared. So a and b are my legs. C is the hypotenuse. Okay, let's find the length of the legs. Katrina, what's the length of the bottom leg?
5.
Yep, it's 5 units. So we got 5 squared plus, Denver, what's the length of the taller leg?
12.
Yep, it's 12. Okay, by putting it on the axis, we can see that very quickly. So it's 12 units. And what about C? Do I know it yet? Nope, so I just leave it. Now we do it out. 5 squared gives me 25. About 12 times 12? 144. Okay, add them up. What's 25 and 144? 169. And now, how do you get rid of that exponent of 2? What's the opposite of squaring? Yep. Yep, square root, square root. Square root and square cancel. You're left with C on the right by itself. And what's the square root of 169? You can. This one actually comes out nice.
Okay.
13.
Yep, 13. Okay, so in your book, I think the way they found the length is they used the distance formula. But for now, we did the Pythagorean theorem. We'll try the distance formula later. Comes out the same. Any questions on that? Now, what if you had placed your triangle there? Would that change the length of the hypotenuse? No. It's going to have the same length, it's just in a different spot. The coordinates aren't going to be as nice. So if you did use the distance formula, every coordinate here is going to have numbers other than 0. Okay? I think that way's easier if you use the distance formula. Okay? Arithmetic should be easier. Okay, let's look at this one. Next, this one is, let's see, this is example 3, okay, in the book. I need to label, this is M, this is O, and over here is K. Right, so they said triangle MLO is congruent to triangle KLO. Find the coordinates of point L. Okay, let's do this one. I know we can kind of just look at it on the grid and figure it out, but let's use this fact. Anybody think, how can you use that fact? Triangle MLO is congruent to triangle KLO. What does that tell me about L? That makes L something special. Yeah? Yeah. So we know that ML is congruent to KL because of CPCTC. Get the corresponding parts. So if that length is equal to that length, something in the middle, that's the definition of a midpoint. Okay? So let's use our formula to find the midpoint. Okay? So to find the midpoint, okay, between 2 points, let's write that down. How would you do that with numbers? What do we call that? Like if you got a 70 on a test and a 90 on a test, and I wanted to know the midpoint of those grades. We don't call it the midpoint, but I'm asking you what we normally call it. That's the name I'm looking for.
Average.
Yeah, it's the average. Okay, that's exactly what you do to find the midpoint. Okay, so let's say you have 2 points. Let's call the first point x1, y1. Okay, the second point, point B. It's got coordinates x2, y2. If you want the midpoint of A and B, okay, the way you do it, take the average of your x's. Okay, how do you average two things? What do you do with them? Add them up. Yep, and divide by, in this case, 2. Okay, so to find your midpoint, add the x's up, divide by 2. Add the y's up, and divide by 2. That's how you find the midpoint. Just average the x's and average the y's. Okay, so let's look at our 2 points. We've got 0, 160, and 160, comma 0. Let's find the midpoint of those 2 points. Okay, Rose, what's x1 in this case? Yep, 0. And what about x2? 160. Divide by 2. Okay, Selena, what's y1? Yep, that's 160. That's y1 and x1. And y2 and x2. Okay, plus 0. So this time it's kind of a coincidence that the x and the y, they come out the same. So what's my midpoint? Yeah?
80, no, 40. Because
So half of 160?
is 40.
What's half of 16?
Um,
8. So half of 160? Yeah, 80. So yep, there's your midpoint, 80, 80. Again, midpoints don't always have to come out with the same number for x and y. Just use the formula and see what it comes out to. Okay. Any questions on that one? So 80, 80, that's your midpoint. Okay. And was there anything else they wanted? Nope. That's it. Now, if they didn't tell you that those triangles were congruent, we can't assume it's drawn to scale, so we don't know if that was really a midpoint. But because they did tell us that, that's why we could use the midpoint formula. All right, let's look at this one. So in this one, they're going to give us the coordinates of two triangles. Okay, that's the given. The given is going to be the picture. And we want to prove that SO bisects angle PSR. So what are we really trying to prove? We're trying to prove that SO is a what? Or I could give you a hint and say SO is an angle bisector. Yes. Okay, we're trying to prove that it's an angle bisector. So to prove that something is being bisected, what does that mean? If it's bisected. Yep.
Cut exactly in half.
Right, we've got to prove that if you look at angle PSR, which is the top vertex of that red triangle, you've got to prove that each angle, okay, on each side is equal, that it's congruent. Right? If what's on the left is congruent to what's on the right, then you've cut it exactly in half. How could we go about doing that? How can we prove that those angles are congruent? What do you think we could show first? Yeah?
Well, we know the placement of the two base angles. So then, if we know those two, I know.
Sure. Anyone? So that's all right. It's okay. You're thinking it through. Anyone else have a thought? Just kind of not anything specific, but just kind of a general idea. If you want to show these two angles are congruent, what do you think you're going to have to show first? Okay, that's going to be part of it.
The triangles are congruent.
Yeah, you're going to have to show that triangle, let's say, POS is congruent to triangle ROS. Okay, if you can show those triangles are congruent, then the corresponding parts are congruent, then you're done. All right, so somehow we have to prove the triangles are congruent. All right, so let's see what we got here. All right, so let me draw in kind of this line right here. Separates it into two triangles. All right, let's start by finding the length of the bottom side of each triangle. And then maybe we could find the vertical side. And those are going to be easy because one's horizontal, one's vertical. You could find the hypotenuse, but then you're going to have to use the Pythagorean Theorem. And I don't think it's going to be necessary in this problem. All right, so let's write down what we want to show. Sometimes they abbreviate that WTS, want to show. Okay, so we want to show triangle POS is congruent to ROS. That's kind of our goal. Any question on the goal? Okay, let's start by finding the length of segment PO. Okay, let's start with that. Okay, what's the length of segment PO? We don't even have to use a formula. We can just look right at it and get that length. Yep, Connor?
3.
Yep, and actually we don't need that. Yep, that's 3. Okay, let's find the length of RO. Okay, so I'll do things over here for triangle POS, and I'll do things over here for triangle ROS. Okay, James, how long is side RO?
3.
It's also 3. All right. Let's look at side OS. Okay, let's find that length. Okay, OS, all we have to do is measure straight up. 1, 2, 3, 4. So OS is 4. But OS is used in both triangles. So we can count that side twice. Okay, and what about that angle in the corner? What do we know that angle would be? Yeah?
90.
Yeah, we know it would be a 90. Okay, one way we could find that is,
We would have to prove it first and then do it because,
yeah, you could prove that.
well, we have to prove both triangles are congruent to itself because we don't know that's a midpoint yet.
Right, we don't know that that's a midpoint yet. But the way we could show that this is a 90, you could use your slope formula. Okay, what's the slope of a horizontal line? Instead of going through it, I'm just going to hope we know that. No. 0. Horizontal line has a slope of 0. Okay, and I know that this side is horizontal. Okay, just by looking at the picture, it's going right along the axis, and I can look at the coordinates. Okay, the y values are the same. Any points that have the same y value, and you connect them, that makes a horizontal line. How about OS? What's the slope of that? Yeah, that's undefined. Okay, and I know it's a vertical line because the x values are the same between points O and S. The y values are different. Okay, that gives me a vertical line. So anytime you have a horizontal and a vertical, that makes a perpendicular. Okay, so you have a 90 and a 90. So angle POS is 90, and angle ROS is also 90. Okay, I think we've proven those triangles are congruent. What's the reason? That, matching that.
Side angle side.
Yep, side angle side. Okay. So now we can say triangle, let's see, POS is congruent to triangle ROS by side angle side. Okay. There really are no formal reasons for the other steps. We used formulas, slope, and then just directly measuring. Okay. Okay, now that if we know those triangles are congruent, all their corresponding parts match up. So now we can say angle PSO is congruent to angle, how would you say the other one? If you said PSO? Yep, RSO. Okay, and what's the reason that those two angles are congruent? You use those letters to abbreviate it? Yep. CPC, TC. Yep. Corresponding parts of congruent triangles are congruent. So now if those angles are equal, we can say by definition, SO is an angle bisector, okay, because it cut an angle into two equal parts. So there's a coordinate proof. So it's a little different than statement reason because you don't have as many reasons. We had a couple, like SAS, CPC, and then we had a definition. But other than that, we just used direct measurements or formulas. So we didn't really need reasons. Okay, any question on that? Now, this triangle, the proof we just did, applied to a very specific triangle. It applied only to the triangle that had vertices -3, 0, +3, 0, and 0, 4. If you want to prove a statement about a triangle in general, you need to use variables for the coordinates. Okay? You can't use actual numbers. It's kind of like if I said to you, prove to me that anytime you add an odd number to an odd number, you get an even number. Well, you can show me a bunch of times. You can say 1 and 3, okay, that's 4. 4. If you add 5 and 7, you get 12. But showing me that it works a bunch of times using specific numbers doesn't prove it in general. Doesn't prove it for every 2 odd numbers in the world. All right, so that's where we start to use our variables. Okay, here's example 4 if you set it up with variables. Okay, let's look at the difference. Okay, the difference when you set it up with variables, you usually don't use a grid. Okay, because a grid implies you know an exact location, you know a number. We don't know a number here. But what we've done is we put the triangle symmetrically, cut by the y-axis. So whatever point along the base, if I go to the left that many units, -h, I've got to go to the right that many units, +h. That's how you split something symmetrically. And the last two coordinates were both 0 because that's the height off the y-axis, x-axis. We're not off the x-axis at all. Our height is 0 for each coordinate. Now for the other one, the vertex at the top, S, we can't really use h again. Okay, h had to do with this distance from on the base. Okay, so we gotta use a different letter because the triangle, we don't know the height of it, so we just pick something different, k. But we do know that it's right on the y-axis, so the first coordinate is 0. Right? And you could do this exact same proof that we just did with letters like that. Right? And that would prove it for every single case where h and k could be any numbers you want. Not just a -3, a +3, and a +4. Any question about how we set up that diagram on the right? I would say for this particular proof, that would be the best place to put it. If you decide to start placing your triangle up over there, that's going to make your proof a lot harder. Okay, try to position the triangle in a good spot. Right, so let's try one with some variables. Okay, it says we have triangle OBC, and it has lengths of h units and k units. Now this is a right triangle. So how should we try to position it? I think we did this earlier. What's kind of the best place you could fit a right triangle? In which quadrant? Yeah. Yeah, try to put it in quadrant 1. And where do you want the sides of the triangle? You want them right along the what? Yeah, try to put them along the x and y axis. Okay. Now, in our book, they did half of that. They put the bottom side along the x-axis. They didn't put the height on the y-axis. I probably wouldn't have set it up that way. I think I would have kind of flipped it around and tried to put the height on the y-axis. It would have made it a little easier. But that's not bad. You also got a coordinate at 0, 0. Okay, so sometimes that helps too. Try to get a vertex right at the origin. All right, so they want us to do two things. Find the coordinates of points B and C first, and then we'll find the length of the hypotenuse. Okay, let's start with B. What's going to be the coordinates of point B? Think about how far over you got to go from the origin, and then think about how high up you go. Okay, let's just start with how far over do you go from the origin? You go over h. Okay. So the x coordinate here is h. You go over h, and then how high up? 0. We don't go up at all. So the coordinates for B are h comma 0. Right, now let's write the coordinates for C. Okay, start with how far over you went, and then how high up did you go. Okay, so Selena, how far over did we go to the right to get to C? Yeah, we go over the same amount. B and C are in a vertical line. So they both have the same x coordinate. How high up? Yeah, we go up k. So there's our coordinates for k, for C, hk. Any question on your coordinates? Right, now let's find the length of the hypotenuse. When we do that, are we going to get a number here? No, we're not going to get a number because we don't have numbers. We have h units and k units. Okay, what's that theorem we use to do this again? What's it called?
What's it again?
Yeah.
Pythagorean Theorem.
So,
It's some Greek word. I don't know how to pronounce it.
so it's Pythag or Ian. Pythagorean. It's named after someone, Pythagoras.
Jeez, he must have a really hard name to pronounce.
He did. So what? Now, more importantly, what's the equation for it? Okay, a squared plus b squared equals c squared. So we need the length of our legs, and that'll give us hypotenuse. What's the length of one of our legs? H. Yep. So we have h squared. Okay. What's the length of my other leg? About Alyssa? K. And do I know the hypotenuse, or is that what I'm finding? Yeah, that's what I'm finding, so just leave that. Okay. Now, normally you would take and square this and square k, but you can't because they're not numbers, so there's nothing else to do here. How do you get rid of the exponent on C?
Square root.
Yep, just take your square root. So the final answer is, it's the square root of h squared plus k squared. Now, if you had a specific problem where somebody told you what h and k were, if you knew the coordinates of b and c exactly, all you'd have to do is use this formula to find the length of the hypotenuse. Square h, square k, add them up and take the square root. Okay, any questions on that one? All right, so let's finish up. I think we got one more, and then we'll stop. Yeah, be our last one. Okay, so this is a proof like we've done before. They just want you to prove two triangles are congruent. So, bless you. They want you to prove OTU, the triangle on top, is congruent to UVO, the triangle on bottom. Okay, anybody see how we could do that? Is there anything we at least can say right away? Maybe if they share something.
OU, or segment OU is.
Yep. Yeah, segment OU is congruent to itself. So let's I'll try to organize this a little bit more for you. Statements and reasons. So Connor said OU is congruent to itself. That's reflexive. All right, so besides that, I want you to look at the top side and the bottom side. Okay, what do you know about the top and the bottom side here? They are parallel.
They're not marked.
It's not marked as parallel, but because of the coordinates, you know they're parallel. Okay? Look at the y-coordinate on t and the y-coordinate on u. How do the y-coordinates compare on t and u? What's my y-coordinate on point t?
The same value.
Yeah, it's k. Okay? The y-coordinate on u is k. They're the same value. Yeah. So if you have 2 points that have a y-coordinate that's the same, that's a horizontal line. Okay? How about my y-coordinate on point O and point V?
0, 0.
They're 0, 0. They're the same. That means the bottom side is horizontal as well. If you have 2 lines that are horizontal, they are parallel. Okay? Now, what does that mean? If we have 2 parallel lines, what else could I say there?
Well, not necessarily.
We don't know if they're congruent, but parallel lines and a transversal tells us something. Is there any
Oh,
angles there that would be congruent?
yeah.
Which ones?
TUO
Yep. TUO
and UOV.
and UOV, yes. 2 parallel lines cut by a transversal. Okay, you have alternate interior angles are congruent. All right, so if you wanted for step 2, you could say TU is parallel to OV. Reason? They have the same slope. 2 lines with same slope. Step 3 is what Connor just said. Angle TUO is congruent to, which one did you say, Connor?
UOV.
Okay, that's fine. UOV. Okay, reason? That's the alternate interior angles theorem. Angles theorem. Not the converse, just the theorem. Okay, in step 4, I think we're going to need either another angle or another side length. It's probably easiest to find another side length. Let's find the length of TU.
Wouldn't it be another alternate interior angle, and that would be angle side angle?
Well, we could, if we proved some other lines were parallel, we could.
Well, no, we can do
Yep.
angle UOT and angle
Now remember, UOT doesn't,
UOT.
it's not part of the parallel lines though. You've got to pretend like that left and right side don't exist. Yeah. Yeah. How about the length of UT? Do they have the same y value, UT?
Yes.
Yeah, they have the same y value, so there's no difference in the height. There's only a difference in the horizontal. So how far is it from T to U on that horizontal? Think about, let's say on a number line, if you were at 4 and you wanted to know the distance to 7, what do you do with 4 and 7? Subtract them. So take the bigger one, subtract the smaller one. What's m plus h minus m? H.
Oh, it's M plus, I thought it was MTH.
Oh yeah, m plus h.
Oh, I was really confused.
Yeah, that's a plus.
I thought it was like an abbreviation of math. And I was like, why would you
Okay.
abbreviate math? It's already short enough.
So the length of UT equals h. What's the length of OV? That's also h. Okay? There are two lines that they're horizontal, the distance between them goes from 0 to h. So that's also h. So is that OV? And the reason for that, that's just the measurement in the picture. You could use your distance formula, but I think because it's horizontal, that's easy enough. You've got that side, congruent to that side. So now why can we say that the two triangles are congruent? Yep, side angle side. Okay, so triangle OTU is congruent. Just be careful you name it correctly. UVO. Side angle side. Okay, so I think the trickiest part here was step 2, realizing you had parallel lines. All right, any questions on that? Okay, so for tonight on 246, okay, I'd like you to try 1 to 15 all, 18, 20 to 23 all, and 26 and 27. And finish up, if you didn't already finish the multiple choice on the MCAS, finish up 7 through 12.